Hello everyone. Today we will discuss the female ovarian follicles. First, let's see a case. 18-year-old Rose had an irregular menstrual cycle since her menarche. Rose realized it may be abnormal for a woman and went to see the doctor. Ultrasound examination indicated that there was a follicular male development in Rose's ovaries. The questions from Rose was, what are the possible reasons and influences of my ovarian follicular male development? To answer Rose's question, you should first be able to list the main functions of the ovary, describe the morphological features of the ovarian follicles in different developing stages, and then explain some possible mechanisms for ovarian disorders in patients like Rose. These are also the learning objectives of this session. Shown in this picture are the organs of the female reproductive system. The ovary is the female gallbladder with two functions: production of oocyte and the secretion of sex hormones. In the female pelvic cavity, the ovary is attached to the broad ligament, through which vessels and nerves pass to and into at the hinum of the ovary. At the hinum, besides the blood vessels and the nerves, there is another kind of secretory cells, Hiller cells. These cells can produce androgen in the female. Do you still remember what is the function of androgen in the female? Can you summarize the types of the cell which can produce androgen, since their dysfunction will result in endocrine disorders? This is the lighter microscopic cross-section of the ovary and the low power. The parenchyma of ovary is divided into an outer cortex and the inner medulla. The medulla is composed of loose connective tissue. The cortex consists of a very cellular connective tissue stroma in which the ovarian follicles in different developing stages are embedded. Though the development of follicles represent a morphological continuum, we are used to assign them into 4 stages: primordial follicles, primary follicles, secondary follicles, and mature follicles. Among them, the primary and secondary follicles are undergoing growth, hence also named growing follicles. No matter what stages they are at, each ovarian follicle consists of one oocyte and surrounding follicular cells. Now, let's start from the beginning, primordial follicles, to see the development of the ovarian follicles. Primordial follicles are the smallest and the most abundant follicles. The oocyte is the center of the follicle. It's about 30 micrometers, and the size is obviously larger than the surrounding follicular cells. The key to identify the primordial follicles is the single layer of flattened follicular cells. In the adult ovary, the primordial follicles are commonly aggregated in groups and are located in the cortex just beneath the capsule. The primordial follicles are formed about the 5th month of fetal life, and the oocyte at that time enters the 4th stage of meiosis. They will arise right there and maintain this status from fetal life to puberty of the female without proliferation and differentiation. At puberty, under the influence of the follicular stimulating hormone FSH, secreted by the anterior pituitary. The primordial follicles start to develop in batches to primary follicles. The follicular cells change from flat to cuboid, from one layer to multiple layers. The cytoplasm may have a granular appearance, and they are for this reason also called granulosa cells. As the follicles continue to develop, a thick amorphous layer is visible between the oocyte and the granulosa cells. This is the rulla pellucida. Rulla pellucida is the pink line in hematoxin and eosin stained slides, and mainly consists of glycoproteins. Both the oocyte and the follicular cells are believed to contribute to the synthesis of the rulla pellucida, since the follicles begin to grow only after puberty. The antigenic property of the newly expressed rulla pellucida protein would affect the immune system if the glycoproteins come into contact with the immune cells by accident. In fact, some women with difficulty to conceive do possess rulla pellucida antibodies. This is considered to be the possible reason for some ovarian follicular male development and infertility. At the later stage of the primary follicle's development, small fluid-filled spaces appear between the follicular cells as the follicle reaches a diameter of about 400 micrometers. In the beginning, these are small and can be seen in different places between the follicular cells. Finally, all these small fluid-containing spaces will fuse to form a large follicular antium filled with follicular fluid. The follicular antium is the distinguishing feature of the secondary follicle. So, you can also call it a vesicular follicle. In vesicular follicles, the granulosa cells immediately surrounding the rulla pellucida become elongated and make up the corolla radiata. As the follicles develop and enlarge in size, the surrounding stroma cells form an organized thicker around the follicle. In secondary follicles, it's easy to identify the follicular theca containing two layers, theca intera and theca extera. This picture shows part of the wall of the secondary follicle. Theca intera cells are polyhedral and pale-stained steroid-secreting cells. Under the influence of FSH from the pituitary, theca intera cells synthesize androstenedione, which will be transported into the cytoplasm of adjacent follicular cells. The enzyme aromatase in the follicular cells transforms the androstenedione into estrogen. This is how the female sex hormone estrogen is produced. The theca extera is derived from the spindle-shaped stroma cells with the potential to contract during ovulation after the follicles come to the mature stage. On about the 14th day of the menstrual cycle, one of the secondary follicles in the ovary develops into a very big structure in size. Before ovulation, the oocyte finishes the first meiosis and becomes a secondary oocyte. This forms the mature follicle. Please note that we only have primary oocyte in primordial follicles, primary follicles, and secondary follicles. This is because before it comes to the mature stage, there is low cell cycle change for the oocytes. Just follicular cells proliferation during the growth of the follicle. Only when the follicle develops into mature stage, the oocyte finishes its first meiosis and becomes a secondary oocyte. The mature follicle reaches a diameter of 20 to 25 mm and buds under the ovarian surface. Due to its large size, it's easy for us to monitor it by ultrasound examination in the clinic. Prior to ovulation, the secondary oocyte, rulla pellucida and corolla radiata dissociated from the follicular wall. Due to the contraction of the ceca externa and the pressure within the follicular atrium, the thin follicular wall will rupture and the ovum is released from the ovary. So, the mature follicles end in the release of a secondary oocyte, producing the female gamete for fertilization. Now is the summary on the development of the ovarian follicles. They are composed of two kinds of cells, and there are 4 stages for follicular development. During the development process, the female hormone estrogen is produced. A mature follicle will release an ovum for fertilization. These 2 main functions of ovary are carried out by the development of follicles in the ovarian cortex. If there is a male development of follicles, this will result in dysfunction of female hormone secretion and reproduction. These are the references for this session. Thank you for your attention.